Subprograms are a sequential statement of two types, procedures and functions. The procedures and functions have the same functionality of the common programming languages. Both procedures and functions written in VHDL must have a body and may have declarations. Both procedures and functions can be used anywhere. This means in sequential and concurrent statement. The procedures and functions have different approach in handling the formal parameter. Procedures perform sequential computation and return values in global object or by storing values into formal parameters. Functions perform sequential computations and return a value as the value of the function. Functions do not change their formal parameters. The procedure declaration is used to declare the calling interface to a procedure, procedure identifier, and formal parameter list. Procedure proc example, constant A, signal B, variable C, and file D. Formal parameters are separated by semicolon in the formal parameters list. Each formal parameter is essentially a declaration of an object that is local to the procedure. The type definition used in formal parameters must be visible at the place where the procedure is being declared. No semicolon follows the last formal parameter inside the parentheses. Formal parameters may be constant, variable, signals, or files. The default is variable. Formal parameters may have mode in, out, and out. The default is in. Files do not have a mode. If no type is given, a mode of in is used. Constant is default. The equivalent default declaration of proc example is procedure proc example A in integer, B in out signal bit vector, C out real D file, where the input parameter A has the default type object constant, and the output parameter C has the default type object variable. Procedure body is used to define the implementation of the procedure. When a procedure declaration is used, then the corresponding procedure body shall have exactly the same formal parameters list. After the repetition of declaration, is present an optional declaration section and then the sequential statement section delimited by begin and end procedure keywords, followed by the procedure identifier and semicolon. The optional declaration section can consist of subprogram declaration, type declaration, subtype declaration, constant, variable, and file object declaration. Declaration of signal is not allowed because procedure is a sequential statement and the signals can be declared only in concurrent section. The function declaration is used to declare the calling and return interface to a function. Function identifier, formal parameters list, and return type. Function returns only one argument. In this case, rand return float, function sum returns integer. A function is usually called within an assignment statement and expressions. It can return only one argument. Instead, a procedure can return more than one argument, and its call is used as statement itself. Formal parameters are separated by semicolon in the formal parameters list. Each formal parameter is essentially a declaration of an object that is local to the function. The type definition used in formal parameters must be visible in the place where the function is being declared. No semicolon followed the last formal parameter inside the parentheses. Formal parameter can be constant, signal, or file. The default is constant. Formal parameters have only mode in. Files do not have a mode. A function must contain at least one return statement and must end with the execution of a return statement. As seen for the procedure, function body is used to define the implementation of the function. When a function declaration is used, then the corresponding function body shall have exactly the same formal parameters list. After the repetition of declaration, is present an optional declaration section and then the sequential statement section, delimited by begin and end function keyword, followed by the function identifier and semicolon. The option declaration section can contain subprogram declaration, types and subtypes declaration, constant variable and file declaration. Declaration of signal is not allowed because function is a sequential statement and signal can be declared only in concurrent section. In this example, we see how to declare a procedure. In the declarative part of the architecture, there is the declaration in the body of the procedure add sub. In this case, the input and the output operand are defined as signal. These allow using the procedure call in the concurrent section of the architecture. The procedure call can simply be implemented writing procedure name with argument into parentheses. The signal SOP1 and SOP2 will be modified by procedure call. In this example, we see how to declare and use a function. In the declarative part of the architecture, there is the declaration and the body on the function add. In this case, the operands are signals, and the direction is not defined because the function formal parameters can only be input. There is the return type, in this case of an integer type. The function call in the concurrent section of the architecture is used to assign the return value of the function add to the s_add signal.